I'll put these up here, and then I'll move that left side. The first one is the SSS triangle congruence theorem, and the second one is the SAS triangle congruence theorem. I'll slide that over a little bit. SSS says if three sides of one triangle are congruent to three sides in another triangle, then the triangles are congruent. And a picture of that, you'd obviously need two triangles. And you'd look for markings. Again, we're looking for markings. So if I have a marking here and a marking here, and then another marking, only using two there, and then three here, that means that this side is congruent to this side is congruent to this side, and this side is congruent to this side, and therefore the triangles are congruent. And everything about them, the angles must be the same as well because of the SSS triangle congruence theorem. For SAS, I would have a triangle. Again, I need a marker. I'm going to have a triangle. I know the length of a side. Let's make this one, well, I'll just give them markings. Side and side, and I know the angle right between them. Then that has to be the same as another triangle that I know the length of those same two sides and the angle right between them. Because that angle is locked in, this third side, which I'm about to draw, has to be the same length as this other side right here. Okay? So having side, angle, side is the same as side, angle, side. These triangles have to be congruent. Which means after I see those side angle sides, I know that this angle is congruent to this angle is congruent to this angle, and this side would be congruent to that side, and the whole figure is congruent to the other whole figure, because I had side angle side marked. If I have two angles that I know, whoops, let me move that back here. So here's my two triangles, and again, generic markings are going to be what we do on these. Those are pretty bad looking. If I've got two angles in this triangle that I know, and they correspond and are the same as two angles in the other triangle, and I know the side between them, then I can conclude that those entire triangles are congruent by the ASA congruence theorem. Angle-angle-side congruency theorem says, once again, of course, I've got two triangles. Okay, and if I have to know two angles, I'll go red here. I've got to know two angles in each one. I know that that angle up top is congruent to another angle in this triangle, and I know that that angle on the right is congruent to another angle. And I need to know at least one side, but in order to be angle-angle-side, that other side doesn't have to be between the sides. If it was between the angles, if it was between the two angles I know, it would be ASA. But that other side would be outside two angles. And so if you look at it, it goes angle, angle, and then side. And over here, angle, angle, and then side. And the side is outside the two angles, not between them. Because if it was between them, you would have ASA, like you have up here. What are your questions?